Hello, today I'm here to explain about a classic problem of synchronization using Semaphore. So in this, we'll see how to write a program to simulate the concept of the Daring philosopher's problem using C or C++ or Python. So here I'm in this code I'm using C. So here first I have given a header files, and here I have given a int tph, and fill name means philosopher, and status and how hung, how many are hungry means, and hu and chu. So inside the here I have given a wide one. So inside this wide one I have given a int pos is equals to 0, and x and y, sorry, x and I. Then here it will print the allow of one philosopher to eat at any time. And here I'm using the for loop. So inside this for loop I have given I is equals to 0, I less than how hungry, how many are hungry means, and I plus plus, and position increment. And here in this printf it will it will generate to eat, uh, and philosopher name, fill name. And here in this for loop, x is equals to pos, and x less than how many are hungry means, how hung, and x increment. And and here it will print it is waiting, and fill name. Then here in white2, inside this white2 it will I have given int I, j, and s is equals to 0, t, r, and x. And here it will print, and here it will print, it will allow two philosophers to eat at the same time. And here in this for loop it will be I is equals to 0, and I less than how hung, and I increment. And here in this for loop j equals to I plus 1, and j less than how hung, how many are hungry means, and j increment. And in this if case, abs of inside this bracket hu of I, and minus hu of j. Then it will be a greater than or equal to 1, and abs inside this bracket hu of I minus hu of j not equal to 4. And here it will print the combination, here in this bracket s plus 1. It Then here t is equals to hu of I, and r is equals to hu of j, and s increment. And here in this printf are guaranteed to eat philosopher name, and inside this bracket hu of I, and philosopher name, full name hu of j. And here in this for loop x is equals to 0, then x less than uh, how hung, and x increment. And here in this if case, hu of x not equal to t, and hu of x not equal to r. Then it will be, it will print is waiting, and fill in of hu of x. Then inside this int main it will be int I. Then it will print the enter a total number of philosophers, and it will scan from the user. And here again we are using the for loop. So inside this for loop I have given I is equals to 0, I less than tph, and I increment. And inside this it will be fill name of I equals to I plus 1, then status of I equals to I. Then it will it will print the how many are hungry. Then it will scan from the user. Then if how many are hungry equal to tph, then it will print all are hungry, and deadlock stage will occur. Then print then it will exit. Then or else it will be for I equals to 0, I less than how hung, then I increment. Then it will print the enter the, it will ask to enter the philosopher position. Then in bracket I plus 1, here it is. Then it will scan from the user, and status hu of I equals to 2. Then in this do case, then here it will print a 1 can eat at a time, and at a second it will show 2 can eat at a time, and it will accept. Then it will ask to enter your friends. Then it will scan from the user. Then in the switch case, in a case 1, in a case 1 it will be a 1, and it will break. And in case 2 it will break. Then case 3 it will print a exit, and default it will print a invalid position. And in this then while of 1. We will run. Now we'll run and see. Is asking to enter a total number of philosophers, so I will keep here a 5. Now it is asking how many are hungry, then I will give a 2. Then it is asking to enter a philosopher's first position, so I will give 2. Now it is asking the second position of the philosopher, so I will give a 5. Now it has printed a 1 can eat at a time and 2 can eat at a time, then at 3 exit, and it is asking to enter your choice, then I will give a 2. Then all 2 philosophers to eat at the same time, and combination 1 it has showed, and now it is asking enter your choice, then I will give a 1. I'll give 2. Then it has printed. Then here it has given P3 and P0 are guaranteed to eat, and 1 can eat, and at second 2 can eat and 3 exit, and I have given a choice 2. Then it has allowed 2 philosophers to eat at the same time and combination 1, and here is P3 and P0 are guaranteed to eat. So now it is asking to enter your choice again, though so I'm giving a 1. So here it has given allow 1 philosopher to eat anytime. So P3 is guaranteed to eat, and P3 is waiting, and P0 is also waiting, and P0 is guaranteed to eat, and here P0 is waiting. So here I will give a 3, enter your choice. So it has exit. So now the program is executed successfully. Thank you.